Welcome to 31st lecture on numerical analysis. In this lecture we will study Weddle's rule for numerical integration. Before this we have studied Simpson's rule for numerical integration that uses a formula like this. The formula for Weddle's rule is very similar to the formula we studied for Simpson's rule in our last lecture. Here f of x naught and f of xn are multiplied by 1. The h is the same as we studied for Simpson's rule. It's p minus a divided by n, and the odd numbered f of x is f of x1, f of x3, f of x5 are multiplied with 5, 6, then 5, then 6, then 5, whereas odd numbered f of x's are multiplied by 1. f of x2, f of x4, f of x6, they are multiplied by 1, whereas odd numbered f of x's are multiplied with the sequence 5, 6, 5, 6, 5, 6. They keep on going, right? So in order to evaluate it, we have developed a spreadsheet like we developed for Simpson's rule, so that we can make calculations quickly. The advantage of this spreadsheet is that make calculations easier for you. So you have to put a here, you put b here, and this formula, the formula that we discussed here, is implemented here. 3h over 10, h2 plus 5, h3 plus h4, and so on, right? So what you have to do is, in order to evaluate a given integral, for example this one, example number 1, you have to put limits a and b first here in this sheet. 0 and 1. What are the limits? 0 and 1, and f of x is x squared, and let's put it x squared here. So let's put it x squared. These are the sub intervals we discussed last time. We discussed in our last lecture x squared, right? And then we copy this formula for all cells, and we reach to an answer 0.333, and this answer is the same as the exact answer we have computed using normal integration. We are using the integration technique that we studied in school and college, right? And let's move on to another example where we evaluate the same integral, but this time using limits from 0 to 2. So 0 to 2, all the things are the same, and the answer is 2.66, and the exact answer is also 2.66. so it's very accurate. Even Weddle's rule is very accurate. You can do that by hand too, using paper and pencil, but this spreadsheet makes calculations easier, right? So example 3 is x squared plus x evaluated from 0 to 2. From 0 to 2, x squared plus x. This is x squared plus this x again. This gives you x squared plus x, and evaluate and copy this formula for all other cells. The answer is 4.66. Let's see what the exact answer is. Oh, it's also the same, 4.66. Example number 4, 1 over x, limits from 1 to 2. Limits from 1 to 2. 1 over x, f of x is 1 over x, so this is 1 divided by this x, and if we copy this formula for all cells, the answer is 0.693, and the exact answer is also 0.693. That's great. Let's move on to the next example, example number 5, where it is 1 over x. 1 over x, it's also 1 over x, but this time the limits are different, 3 and 5. So between 3 and 5, f of x is the same, but this time the limits are 3 and 5. So the answer is 0.51, and it is the same as the exact answer. And let's move on to example number 6. It's e to the x, and the limits are from 2 to 4. From 2 to 4, and f of x is e to the x, exponential of x. And if we evaluate it for all possible values of x6, x0 to x6, the answer is 47.209. 47.209. The exact answer. Percentage error is 0. And let's evaluate the last integral, sine of x from 0 to pi. From 0 to pi, you know, in radians pi is 3.14. So by default these spreadsheets take radians by default. So if you compute sine of 3.14, that would be sine of 3.14 radians, which is equal to 180 degrees. Right, so let's sine of E2. Right, and we evaluate. The answer is 1.999 or 2. So let's see what the exact answer is using the integration we studied in school, and we applied that method. The answer is 2, and here the answer is 1.999. So even Weddle's rule it works fine. It gives you the resolution of a definite integral very close to its actual value. So that's all for this lecture, but at the end of today's session we have a homework. You need to try different integrals from your FSC or A-level mathematics book and evaluate those using this spreadsheet. This spreadsheet means this Weddle rules spreadsheet that we have discussed in this lecture, and of course that would be an interesting exercise. So soon I will be sharing this sheet and the sheet that we use for Simpson's rule, so that you can make different experiments. Right, that's all for this lecture. Thank you.